here, Control plus. Here we go. That's big enough. Um, let's see over here. What do they want? Let me find my pen. Where's my little pen? Oh, it's right here. Okay. The table below show the percentage of a country's labor force in unions for selected years between 1955 to 2005. Complete parts A to D below. So they give you a table. Um, one row is year from 1995, and the increment is 5 years until year 2005. And then the second row is the percentage. So the first question they ask you, make a scatter plot of the data. Which kind of polynomial model seem to be most appropriate? Let X be the number of years after 1900 and let Y be the percentage of the labor force in unions. Which of the following is a scatter plot of the data? So you can see over here, let's see over here. You see over here, the year going up every 5 years. And now you take a look at the row for percentage, and you can see the value also not going up, but going down. So it's the model should be a line, but the line going down. So I would choose the option C over here. Okay, option C. And then I click check answer. So it's a line. So the next question is, what kind of polynomial models seem to be most appropriate? A line, it means it's linear. So I click on linear, final checks over here. And now they ask, use a graphing calculator to find the type of model from part A. So I would use decimal graphing calculator. So I have it set up over here on the right side. Okay. I try to make a little bit bigger so you can see what I'm doing here. Okay, let's see here. Okay, so first of all, I click on the plus sign here. The plus sign, you can see the plus sign right here. Okay, and I choose table. So the table will come out two columns, x1 and y1. So go back to the problem over here. I will enter all the value of x1 based on the year. But keep in mind, they said x is the number of years after 1900. So for year 1955, just think it's like the age. You take 1955, you subtract 1900. So for 1955, I only enter 55. Okay. I can take care of all the value of x1 first and then take care of the value of y1. I can do that. So the next year is 1960, which is 5 years after 1955. So 1950, I subtract 1900, I come out 60. All right. And now I can keep pressing the enter key, so it will come out with the next value of x1 with increment is 5. So I keep pressing until year 2005. It means the x value is 105. So I can stop now. And now I go back to the value y1 that go with the value of x1 of 55. So I have to enter over here. Under 1955 is 33.1. So make sure I enter the number exactly. Okay. and I can move the cursor down. For 1960, I enter 31.3. For 65, it means 1965, 28.3. All right, 1970, which is 70 for X1, I enter 27.3.2, I mean. And for 75, enter 25.6. For 80, I enter 21.9. And then 1985, X1 is 85, I enter 18. For 90, I enter 16.5, 16.2 I mean. And then 95 is 15.1. And then 2000 is made 100 for the X1. For the Y1, I enter 13.5, 13.4 I mean. And then the last one is year 2005. The X1 is 105 and the Y1 should be 12.4. So I complete my my table. Now I need to find the equation. And earlier we already said this is a line, a linear line. So for the linear model for regression, I need to enter. Normally the equation for a line is y equal mx plus b. But for a linear model for regression, I enter y1. Okay, because the y1 is reading from the column of y1 over here. Okay, and then I enter tilde. So I can put a x1 and then plus b. Okay, so a is a slope and b is the y-intercept. Okay, so make sure you enter y1 tilde a x1 plus b, because the x1 and the y1 is reading the information from the table x1 and y1 over here. So instantly we find the value of a and the value of b, and if you notice the value of a is negative because the line, go back over here, the line is going down. So going down, so the slope had to be negative. Okay, so I can enter my answer over here, but make sure read the requirement of it. They said round to 3 decimal places as needed. So I enter negative 0.444 x, and then plus b. B happened to be 57.58. That's it. Check my answer. Bam, it's correct. Now, question C. Use the model you found in part B to predict the percent of the labor force in unions in the year 2021. Okay. So let's go to the graphing part of here. Okay, I zoom out. Oh, here we go. You see that? So all the value of x1, y1 right here, and then the red line is the linear model, okay, of these x1, y1 values. So now we got the equation. So you can substitute the value of x with 121. Okay, do not substitute 2021. Remember, x is a value of years after 1900. Okay, so let's do that. You can use your calculator, but I can use graphing calculator. So I re-enter over here y equal negative 0.444 x, and then plus 57.58. Okay, and then I go up here. Look at the wheel over here. I click on the wheel. and I choose table. If I do that, and then over here, if I enter the value 121, okay, instantly I come out with the 121 for x, I come out with the y value right away. Okay, so 3.856. But pay attention over here, they ask you to round to one decimal place and it. So I would enter 3.9, 3.9, 3.9. Okay. Ta-la. Now the next question is, they ask you, do you have much confidence in this prediction? Explain. Okay. So look at the data over here. Go back to the table. The data listing from 1955 all the way to 2005. And now they ask you to make prediction at the year 2021. 2021 is outside this range. Okay? So the answer would say not confident. Not confident. The reason is since the prediction is extrapolated, okay? Because the year 2021 is outside of these data, okay? The data is only from 1955 to 2005, and year 2021 is outside. So the answer is you don't have much confidence since the regression is extrapolated. Okay. So if you do this question again, and let's pretend that they make the prediction, let's say year 1999, for example. So 1999 is between these range from 1955 to 2005. So on that case, the answer is yes, because the prediction was interpolated. Okay. Thank you so much for your attention.